All right. Let's take care and look at proportional relationships. You're looking really that I can identify what is a proportional relationship, and I can use my equivalent ratios that I talked about, I used yesterday to work on those. So first thing we got to get is the idea of what proportional is. So if you think about a proportional response, you're looking for something that fits the crime. So if you normally study in 6th grade something about Hammurabi's code, you look at ancient Babylon, you look at those civilizations, and one of the most common things, and even from the Bible, is this idea of an eye for an eye and a tooth for a tooth. That was in, I want to say it's in Leviticus. That's a proportional response. You get they're equal to each other. That's what proportional response is in a regular idea, but in a mathematically way, we're going to say that it is a line that goes through the origin or starts at 0, 0, the origin, with the exact same ratio. And a line means we're talking a straight line, not one that's curved or jagged or changing lines. So if that's a proportional line, a non-proportional line is something that either does not have a constant ratio, goes up and changes by different amounts, or does not go through the origin. Those are ideas of non-proportional ideas. So, and then finally, the idea, when we talked about using equivalent ratios, an equivalent ratio is two ratios that express the exact same relationship between the numbers. So we're talking probably something as simple as 3/6 and 1/2. While they're different numbers, the relationship between 3 and 6 and 1 and 2 is the same. They're both equivalent to each other, even though they're using different numbers. I'll give you a second to write any of those down. Go ahead and feel free to pause it if you need to go before I move on. All right, so now that we've kind of looked at our vocabulary, let's talk about proportional. So we'll start with Jordan here. So we want to think about this idea. So those two questions of proportional we're looking at is the origin and constant rate or straight line, depending if we're looking at a graph. Okay, do they make the same amount every time, and do they start at 0, 0? So those are the two questions we're asking ourselves. If we're going to go ahead and answer a question, that's what we're looking at. So does Jordan is his answer proportional? So the first thing you have to say is, the answer happens to be yes, he is proportional. Helps if I'm not using white ink. Let's go with this bright green. Yes, it is proportional. And why? Now, you got to tell me, because it is there's two conditions they need to meet. You've got to tell me that because if he does not work, he makes $0. We'll use $0. And he makes the same amount per hour for each hour. He doesn't make more money 1 hour than the other. He makes $18 per hour. So that's what we're looking for proportional. We're looking for that. It goes to the origin. It starts at 0 in real life, and they make the same amount every hour. So those are our two pieces. So take a second, and you guys figure out, is Jeffrey walking 6 miles per day a proportional relationship? Well, let's take a look. So I'll give you, pause the video if you need to write your answer, but we're really looking at these two things. Does it go through the origin? If he doesn't walk at all for 0 days, does he go anywhere? That's correct. He does not walk. If it's not been 1 day yet, he hasn't walked at 0. Does he walk the same amount, a constant rate? Yes. Therefore, this one is proportional. That's the two things we're exploring. So let's take a look at another problem. So Uptown Tickets charges $7 per baseball game plus a $3 processing fee per order. Is this proportional to the number of tickets ordered? Well, one of the easiest ways to test this kind of problem is to see if I make myself a simple ratio table like we talked about in a previous lesson. We looked at these yesterday, where I create myself a number of tickets and the cost. So if I order one ticket, I'm going to pay $7 per the ticket and a $3 processing fee. If I order 2 tickets, I'm going to pay $7 per ticket, so that's $14, plus that $3 processing fee of $17. If I buy 3 tickets, that's going to be $21, plus 3 is $24. So I'm going to look, are these equivalent ratios? Well, this is 10 over 1, or 1/10. This one is 8 over 1. And since they're not equivalent, if you bought 0 tickets, You didn't make an order, you'd be 0, 0. So that part it qualifies as. But what it doesn't qualify is in the same rate. It changes because of this processing fee. It's added on to the order. So this one is non-proportional. All right, you figure out on this one, that's this cleaning service. Is this proportional? Make your table to see it explains why you're right or not. All right, so let's make our table. We have hours and cost. We'll make a simple T-chart for more of a table. So 0 hours, $0. They don't come and clean, you don't pay them. For 1 hour, they've paid $45. For 2 hours, they've made $75 because that's the $45 for the first hour and $30 for the next hour. For 3 hours, they've made $105. So if I do my math, this is $45, 45 over 1. This one ends up being 37.5 over 1. Well, these two are different. Therefore, it's a non-proportional answer. Good job. All right, let's talk about this. Is this proportional? More real life in a recipe. Does the recipe show is the amount of sugar used proportional to the amount of mix used? It doesn't have to be the same, but if I use 0 mix, so let's think about this. If I use 0 mix, how much sugar do I need to make? I need to know 0. If I used 1 mix, I use half a cup of sugar. What if I use 2 mixes? Wouldn't I use 1 cup of sugar? Is this still the same? Well, this is 1/2 over 1, so that's 1/2. 1 over 2, 1/2. So yes, this is proportional. All right, let's take a look at our next one. You tell me, is this a proportional value? It is. It is proportional. Good job. Oh, I missed my eye there. There we go. So now let's take a look. If I look at 2 tables, can I determine which one of these 2 is a proportional relationship? And you got to tell me why. So take a look. So if we take a look at this, what we're going to look for is that each number, every single one of them has an equivalent ratio. So we're going to say 2 over 5, done. That's simplified. 4 over 10 simplifies to 2 over 5. 6 over 15 simplifies to 2 over 5. They have equivalent ratios. Let's check this one. This simplifies to 3 over 5. This simplifies to 2 over 5. This one doesn't simplify at all. Since these are not constant, you would tell me that if he read 0 pages, he spent no time. Or if he spent no time, he spent 0 pages. And then he has a constant rate. So you're going to tell me, yes, it's proportional, and you're going to tell me because it has a set of equivalent ratios, and it goes through the origin. Okay? And then take this one and give this one a shot. See if Emilio had a proportional relationship or Walter. All right, and again, to prove this, you're going to look at the relationship that each of these is 2/3. This one's 5/6. This one's 1. This one happens to be 8/9. All different. So Walter has that proportional relationship because he had a constant rate all the time for his typing, and if he spent no time typing, he probably didn't type any words. All right, and that kind of gives us our rundown of what we're looking at. One of the parts of your homework, though, just to kind of give you guys a little bit of an idea to take a look at, has ratio tables, but this time it has some negative numbers. So you might have -1, -2, 0, -0, 0, and kind of see. So if you're going to graph this, I just want to talk a little bit about where negative numbers are. So if you're negative on the x-axis, we'll put this over here, and they're all labeled on your homework. -1 over, and you have -2 down. You're looking at to the left 2, 1, down 2, 0, 0. So then we'd have 1, 2. So we go, and we'll do this. So for positives, we know we go this way. We've spent a lot of time in quadrant 1 up here, 1 over 2 up. Now, so if we're doing this on here, we're going to say, okay, that's a proportional relationship. Or you might have to create equivalent fractions to get that idea. So you've got lots of things to take a look at. If you have questions, please reach out. I'd be happy to help you.